So in this video, we are going to introduce polynomial functions. So let's first look at two examples of polynomial functions, and then we'll get into what is the definition of being a polynomial function. So if we look, these are two examples of polynomial functions. F of x equals negative 7x to the fifth plus 8x to the fourth minus 3x to the third plus 7x squared plus 17x minus 2. So notice integer exponents only, okay, and that they are non-negative integer exponents. F of x equals 15 over 18 times x to the 10th minus 3x to the fourth plus 2x. Another example of a polynomial function. If you notice, we're only going to be working with single variable polynomial functions, which means you'll only see one letter. Okay, you won't have different variables, different letters there. So this is another example. Notice this is first, the largest exponent is 10. Notice you don't have to have all descending exponents, okay? It just has x to the 10, x to the 4, and x. So these are two examples of polynomial functions. So if you are a polynomial function, okay, you have non-negative integer exponents. Okay. When you are in standard form of a polynomial, you go largest exponent to smallest. Remember, a constant would really be x to the 0. That's why we say non-negative, because non-negative includes positive and 0. Okay, so if you are asked to put your polynomial function in standard form, which is what you're going to want to do, it's extremely important that your polynomials is in standard form for when you're solving, when you're graphing polynomials. You always put it from the largest exponent down to the smallest. Okay, so these are two examples of polynomial functions. Okay, so now what we're going to get into is classifying polynomials. So, you can classify a polynomial by its number of terms. So we'll make a little chart. Okay, so if it has one term, here's an example, 5x to the 7th, that's called a monomial. So, a two-term polynomial expression, or that fits a polynomial function, I should say negative 3x to the 5th plus 4x, that's called a binomial. So why do we classify by the number of terms? It gives us a better idea of when we're communicating to someone else what exactly we're looking at. So when you say a binomial, you know you're looking at a polynomial that has two terms with it. 3 terms. Okay, that's called a trinomial. And then 4 or more, so negative 5x to the 7th plus 8x to the 6th minus 100, we'll say minus 10x plus 7. We stop giving it a specific name, and we're just going to call them polynomials, okay? It just helps you be a little bit more accurate as to zoning in the person who you might be communicating with, what exactly they're looking at. So when you say polynomial, it can have an infinite number of terms, yet when you say trinomial, you know specifically, okay, I'm looking at a 3-term polynomial function. So you can classify a polynomial by the number of terms, and you can also classify a polynomial by its degree. Okay? Now, before we classify by its degree, we need to know what that means. Okay, so degree is going to be the value of the largest exponent that's on the variable. Okay, so the value of the largest exponent on the variable. So make 3 columns. Okay, so when the degree is 0, here's an example. F of x equals 5, okay, 5. Notice 5 is the same as saying 5x to the 0. This is what we call our constant function. When x is being raised to the 0 power, we're just left with 5 here. What that means is no matter what you plug in, the output will always be 5, therefore it has a constant value. When the degree is 1, so an example of that would be negative 2x plus 3, okay? What do we call a polynomial function with degree 1? It's called degree 1 because the largest exponent on x is 1. You know this. This is a linear function, okay? A linear function is a type of polynomial function. It's the polynomial function of degree 1. Degree 2, 7x squared plus 5x minus 2. You know what this is called. This is called a quadratic function. Okay, so what is a quadratic function? Quadratic function is actually a polynomial function with degree 2. So next up is degree 3. So degree 3 negative 70x to the third plus 7/8. I'm using a lot of 7s here. Okay, a third degree is called a cubic function. Okay, a fourth degree okay, so notice the largest exponent is 4. Therefore, it's degree 4. Remember, degree is the value of the largest exponent. This is called a quartic. And we're just going to classify anything with degree 5 or more. Okay? Let's say n. So it has degree n. We're just going to say that it's an nth degree. So if the degree is 10, we're just going to say it's a 10th degree polynomial. Okay, we're not going to give it a special name. It just helps us communicate what specific type of function we have, because we're going to learn what degree means to us when we get into graphing and when we get into solving. So it has an important meaning. Okay, so let's talk about some things. Important terminology in polynomials. Okay, we've got important terms. We've got degree. So we've already stated, if you have to write down again what degree is going to be the value of the largest exponent. Okay. Leading term. So the leading term is going to be the first term when you're in standard form. So that means it is the term with the largest exponent in it. Okay? And then leading coefficient, this is all going to be important when we are graphing. And then the leading coefficient is the coefficient of the leading term. Okay, so for the following, we're going to put in standard form. Then we're going to state its degree, the leading term, I'll just write LT, and the leading coefficient. Okay, so the polynomial let's say, okay, so we have f of x equals negative 3x plus 4 minus 5x squared plus 2x to the third. So if you're going to be in standard form, you have to do largest exponent down to the smallest, so that means this should be positive 2x to the third minus 5x squared minus 3x plus 4. The degree of this polynomial, you look for the largest value exponent. Since you put it in standard form, it should be the exponent of the first term as long as you are in standard form. So this has a degree of 3. So if we were going to classify it by its degree, this would be a cubic function. So now we have to state what the leading term is. It's the term that's first. So remember what a term is, okay? Classified by terms. It's got a coefficient, variable, raised to a power. So the leading term is the first term when you're in standard form. So the leading term is positive 2x to the third. The leading coefficient is the coefficient on the leading term. What's the coefficient here? 2. So make sure you feel comfortable with the term's degree, leading term, leading coefficient, understanding how to put a polynomial in standard form, as well as remember about classifying by terms. You can have a monomial, binomial, trinomial, polynomial, and then also by its degree. You can further classify. Okay? We studied linear functions, quadratic functions. Now we're actually just going to study all polynomial functions. So the first thing we're going to do is operations with polynomials. And then we get into graphing and then solving. So we just have to make sure we are able to perform operations with polynomials. In this video, we'll cover adding, subtracting, and multiplying. In the next video, we will cover dividing. So we've got adding and subtracting, and remember, what do we do when we're adding and subtracting, right? We combine our like terms. And then we've got our multiplying and our dividing. You've actually done this before. You've added and subtracted polynomials, okay? You've multiplied, but I don't think you've divided more than just monomials before. Okay, so let's simplify each expression. Remember, you need to give your final expression in the standard form. So number 1, let's do negative 3x to the fourth plus 5x to the third minus 2x squared plus 1 plus, let's do 8x to the fifth minus x to the fourth plus 3x to the third minus 2x. Okay, so we're going to add together our like terms. Okay, we see that this is the adding of the two polynomials. So we add together our like terms. Now, we want to put this in standard form as well. So let's first look. This is in standard form, this is in standard form, that's good. So I'm going to look for my largest exponent. My largest exponent is x to the fifth. Okay, so now, do I have an x to the fifth in the left? No. So that means it would be like 0x to the fifth plus 8x to the fifth, and that's going to give me just, in my result, that's going to give me just positive 8x to the fifth. Then, in descending order, I should look for x to the fourth. I've got a negative 3x to the fourth plus a negative x to the fourth. Negative 3x to the fourth plus negative x to the fourth is going to put me at negative 4x to the fourth. Then I should look for what's next in descending order, x to the third. I've got 5x to the third plus 3x to the third. That's going to put me at 8x to the third. Okay, then I would go to x squared. I've got a negative 2x squared plus, and I don't have to add it with anything, so that means I would really have plus 0x squared, which would just be negative 2x squared. And then I should look for the linear term. I have none here, but I have a negative 2x here. So it's like 0x plus negative 2x, so that's going to put me at negative 2x, and then I would look for my constant term, And I only have one here, so this is 1 plus 0, so this would just be plus 1. And as long as you worked in descending order, you know your answers already, I shouldn't say answer, your simplified expression is in standard form. Okay, so that's number 1. Let's do a few more. Okay, number 2. Okay, so in number 2, we have 2 polynomials and we are subtracting. So what you have to remember is you are subtracting this entire polynomial. So you are subtracting every single term in this set of parentheses. So we really have negative 2x to the 4th plus 3x to the 3rd plus 7x squared minus 5x minus 2. So we're really adding all of these terms, the opposite. Okay, we are subtracting each of these terms. So I like distributing the negative and now just looking at all of my terms. So we're going to go standard form, so largest exponent to smallest. So I've got a negative 3x to the 4th plus a negative 2x to the 4th, which is the same as negative 3x to the 4th minus 2x to the 4th. And that's going to put me at negative 5x to the 4th. Okay, then I would look for x to the thirds. I don't have any x to the thirds here, and I have a positive 3x to the 3rd here. So it's the same as 0x to the 3rd minus negative 3x to the 3rd, which is the same as 0x to the 3rd plus 3x to the 3rd. Okay, we keep going. Now we've got 7x squared plus 7x squared because minus a negative made it a positive. So this is plus, whoops, not 7x squared. 7x squared plus 7x squared puts us at 14x squared. Then we would look for our linear term, and we've got a, let's see what we've got going on here. We've got 5x minus positive 5x. That's the same as 5x plus negative 5x. 5x plus negative 5x. They're going to cancel each other out. So you don't have to write 0x. Okay, and then we've got negative 1 plus negative 2, and that's going to put us at minus 3. So what you have to just be careful of is, if it's not in standard form to begin with, I would write the terms in standard form. That way it's a little bit easier to look at. Do you have to? No, but I think it makes it a little bit easier. Okay, number 3, we've got x squared times x plus 1 minus x squared plus 5x plus 1 plus 2x times x plus 3. Okay, so before we can add or subtract, the first thing is we have to do the multiplying. So this new polynomial is going to become x to the 3rd plus x squared minus, and we won't touch that second polynomial yet. That's a trinomial. So we've got the binomial, we've got the trinomial, and another binomial, 2x times x, that's 2x squared, 2x times 3, that's 6x. And so I'm subtracting this entire trinomial, so I might want to distribute that negative so I don't make a mistake. That's going to be minus x squared minus 5x minus 1. So we've got x to the 3rd plus x squared plus that plus 2x squared plus 6x. Okay, so I'll go in standard form order. So I want to look for the first, the largest is going to be x to the 3rd. I've got an x to the 3rd with nothing else, so that's just going to be x to the 3rd. Okay. I've got an x squared, I've got a minus x squared, I've got a 2x squared. All right, so that's just going to give me positive 2x squared. Okay, next would be linear. I've got a negative 5x plus a 6x. That's going to give me positive 1x. And then I've got the minus 1 and no other constant term. So there is our simplified polynomial. Okay, so that's adding as well as multiplying with a scalar. And so now we'll go into multiplying polynomials together. So I'll show you that you've already done this before. Number 4, x plus 1 times x minus 2. You've done this before. This is a binomial, a linear binomial times a linear binomial. Remember, when our distribution property says that each term in the first set of parentheses needs to get multiplied by each term in the second set of parentheses. So if you want to know how many terms is in your product, the number of terms times the number of terms, okay, tells you the total of number of terms you're going to get. So if you don't need a visualization and you can just do what I said, right, make sure the first term gets multiplied by every term in the second, make sure the second term gets multiplied by every term in the second. You'd have x squared minus 2x plus 1x minus 2, then simplify x squared minus x minus 2. There's something called the box method. It helps to see, okay, area of a box is length times width, right? So you let the length of the box be one of the expressions, and you let the width of the box be the other. So this has two terms, x plus 1, and then you let the width be x minus 2, okay? And so we're going to get the area of this box, which is going to be by multiplying, okay? So x times x is x squared, x times 1 is 1x, x times negative 2 is negative 2x, negative 2 times 1 is negative 2. It's just a visually appealing way of making sure you've multiplied out all of your terms. So it could help if you have trouble keeping track of everything. It could help to use the box method. You don't have to. So the reason why you might use the box method is because you might end up with something like this: negative x to the third plus 2x squared minus 5x plus 1 times x squared plus 2x minus 1. Okay, so what we've got is a 4-term expression, right? A 4-term expression times a 3-term expression. We're about to get 12 terms. So if I just go and, draw my arrows to make sure that I'm multiplying everything out, okay, I might mess up. So this might be a good candidate for multiplying using the box method here. Okay, so I've got negative x to the third plus 2x squared minus 5x plus 1. I've got x squared plus 2x minus 1. Okay, so negative x to the third times x squared. That's going to be negative x to the fifth. Notice we went over properties of exponents already because multiplying is going to generate properties of exponents occurring. 2x squared times x squared, that's going to be plus 2x to the fourth. X squared times negative 5x, that's negative 5x to the third. 1 times x squared is positive x squared. 2x times negative x to the third, that's negative 2x to the fourth. 2x times 2x squared, that's positive 4x to the third. 2x times negative 5x, that's negative 10x squared. 2x times 1, that's positive 2x. Negative 1 times negative x to the third, that's positive x to the third. Negative 1 times 2x squared, negative 2x squared. Negative 5x times negative 1, positive 5x. Negative 1 times 1, negative 1. So all of our 12 terms are here. So we just now need to go in standard form, put them in standard form. And we can combine all in one step. So I see x to the fifth as my largest one right here. And I don't have any other x to the fifth, so it's going to be negative x to the fifth. And then I've got a negative 2x to the fourth and a 2x to the fourth, and I don't have any other x to the fourth, so they would cancel each other out. I then have my x to the thirds. I have a positive x to the third, I have a positive 4x to the third, and I have a minus 5x to the third. Those cancel each other out. I've got a negative 2x squared, a negative 10x squared. I've got a positive x squared. That's going to put me at negative 11 squared, x squared, sorry. I've got a 5x and a 2x. That's going to put me at plus 7x, and I've got a minus 1. Okay, so just make sure you multiply out all of your terms. 4 terms by 3 terms is going to produce 12 because this has to go to this term, this term, this term. This has to go to this, this, and this. This goes to this, this, and this. And this goes to this, this, and this. Okay, we're going to do one more problem. number 6, the finale. 2x plus 3 raised to the third power. Is this a property of exponent? Can I just distribute the exponent of 3 to the 2x and the 3? Absolutely not. The property of exponent that says distribute would be if this was a product inside. The only way to simplify this is to write it out. 2x plus 3 times 2x plus 3 times 2x plus 3. And now I multiply out and put this in standard form. You have 3 quantities here, okay? Our rules of multiplying say when we have more than 2 quantities, okay, 3 quantities, you only multiply 2 quantities together at a time. You can multiply A by B, get the product, and then take that and multiply by C. Or you can multiply and get B times C and then multiply that by A. Or if you're feeling adventurous, you might multiply A by C and then multiply that product by B, okay? So, doesn't really matter because they're all the same factor here. We've got to take care of 2x plus 3 times 2x plus 3. So that's going to give me 4x squared plus 6x plus 6x plus 9. I'm going to clean that up before I multiply that by 2x plus 3. Because why multiply 4 by 2 when I can combine like terms and get this to be 3 by 2? So that's going to be 4x squared plus 12x plus 9. And so I've got a 3 by 2. I'll use the box method here. Do you have to? No. If you want to just multiply it out, if you feel comfortable, that's perfectly fine. 4x squared plus 12x plus 9, and then 2x plus 3. So 3 terms by 2 terms, we're going to get 6 terms here. That's going to give us 8x to the third plus 24x squared plus 18x. Okay, plus 12x squared, let's erase that, plus 12x squared, okay, plus 36x plus 27. Now we just got to combine like terms and put in standard form, so it'll be 8x to the third. I've got a 12x squared, I've got a 24x squared, no other x squared, so that's going to be plus 36x squared. So everything seems to be falling nicely in a diagonal. That just happens to be because these are all in standard form and these are just in descending order and they're close to each other. It's not going to be the case if these are not in standard form, okay? Plus, and it's okay, you just look to combine your like terms, okay? So just pick out your like terms and add them together. That's going to give us plus 54x plus 27, and there is our simplified expression. So that's adding, subtracting, multiplying polynomials, as well as an intro with classifications. And in the next video, we will look at the last operation, which will be dividing polynomials.